We're now going to turn our attention to the key methods in the Java Semaphore class. And you see there's a lot of them, but fortunately, we only have to focus on a handful for most normal use cases. The key methods, as you might expect, acquire and release the semaphore. Gee, what a surprise, right? And we'll see that there's really 4 of them, and they kind of mirror what you see in the reentrant lock, although the semantics are a little different. These methods basically forward to the underlying implementation, which extends and customizes certain aspects of the underlying abstract queued synchronizer framework that we talked about before. Acquire atomically obtains a permit from the semaphore, blocking until it's able to do that. I've been having lots of fun lately watching the Agents of S.H.I.E.L.D. TV show, and there's a guy named Agent Koenig who's always handing out lanyards to everybody. So if you watch Agent of S.H.I.E.L.D., you'll remember Agent Koenig, and he's got a couple of, I think he's actually a triplet. So anyway, he's giving out lanyards, kind of like the semaphore's acquire method gives out permits. By default, the acquire method can be interrupted, which means that if you are waiting for a semaphore and someone interrupts the thread that's waiting to acquire the semaphore, that particular method will go ahead and return and throw an interrupted exception. To make things consistent, there's also an acquireUninterruptibly method that obtains a permit from the semaphore. This call cannot be interrupted. So when you're blocked in acquireUninterruptibly, you're basically just going to have to wait until that semaphore is available and you can't interrupt the thread that's waiting. And you have to decide whether it's more important to ignore interrupts or more important to be responsive if something gets canceled. And so your programming assignment should indicate which one to use. I think you want to use the interruptible version because that makes it more responsive to being shut down. Interestingly enough, locks, the reentrant locks are kind of the other way around. I think by default, they will not be interrupted. And then there's a lock interruptibly method, which can be used to be interrupted. There's also a method called tryAcquire, which obtains a permit if one is available at the time in which the call is made. And so that's kind of like tryLock. It'll check to see if the permit's there, and it'll go ahead and return with it if it gets it. But if it's not available, it won't stick around and block the caller. Interestingly enough, and again, this is similar to the untimed tryLock method, the untimed tryAcquire method will barge, which it means it won't honor the fairness setting, and it'll simply take any permit or permits that are available when you make the call. There's also a method called release, and that atomically increments the permit count by 1. And of course, if it goes above 0, then it'll wake up, the mechanism will wake up other threads. Keep in mind, it's valid for the permit count to exceed the initial permit count. So it'll keep going. As long as you call release, it'll keep incrementing by 1. Whether that's the right thing to do in any given circumstance is another story, but it'll do it that way. If the permit count goes from 0 or less than 0 to greater than 0, then that will allow another thread or other threads that are waiting to acquire the semaphore so that they can proceed. And so that ability to notify and wake up other threads is very important to the way that semaphores work. And you'll actually get a chance to implement this when you work on assignment 2B, because you'll implement a simple semaphore using some of the synchronizers that are part of the Java course synchronization aspect of the Java class library. Interestingly, as we've talked about before, the thread that calls release doesn't have to be the same thread that called acquire. So that's just a fancy way of saying that semaphores don't require fully bracketed operations. Now, as was the case with reentrant lock, there's also a bunch of other methods that are part of these synchronizer interfaces. And let's take a look at some of the other methods that are part of Java's semaphore. And actually, there's quite a few of them. Some of the methods can actually acquire or release multiple permits at a time. So you'll see that you have acquire that takes account of the number of permits to acquire, one that takes account and it acquires them uninterruptibly, one that will try to acquire a bunch of permits in a non-blocking way, one that will release a bunch of permits, and so on and so forth. So if there's a reason why you have to grab multiple resources or work on multiple resources, these methods give you a way to do that. There's also some methods that use timeouts. So you can see here that we have tryAcquire, we have a timeout, for just acquiring one permit, and you also have tryAcquire with a timeout for trying to acquire multiple permits. And interestingly enough, and this again completely mirrors what you see with reentrant lock, the tryAcquire methods that are timed will in fact honor the fairness setting, so they won't barge. And it's a little confusing, but you just have to get used to the way things work with these APIs. There's also some methods that provide you with some information about the semaphore and its internal state, like how many permits are currently available, what the length is of the number of threads that are waiting to acquire the semaphore, and also whether there are any threads that are waiting to acquire them at all. So, of course, keep in mind that this information is always just an estimate in a concurrent program, because the moment you call available permits, somebody could acquire or release it. So by the time you get the result back, it might not be that useful. But they're mostly helpful for things like debugging, and probably for the people who wrote the Java Semaphore to write tests to make sure it's working the way that they expect. So that's essentially the key methods in the Java Semaphore. As you'll see when you do your assignment, you only have to be aware of just a handful of these, but I want you to be aware that there are other methods because they do come in handy for more advanced synchronization use cases.